Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to talk about a set of special rules in finding the derivatives of a special type of function, which is the trigonometric functions. And you will see later on that these rules given here are very useful. They are quite helpful in order to speed up the process of finding the derivative of a complex function. And before we start off with the discussion of these rules, I'm going to just talk about some of the basic trigonometric relationships that you should be familiar with. So, for example, if you have tangent theta, so if you have tangent theta is equal to sine theta over cosine theta. So that's the basic trigonometric relationship. And if you have cotangent theta, that is the same thing as 1 over tangent theta, and this will give us cosine theta over sine theta. So next, if you have, for example, cosecant theta, so cosecant theta is 1 over sine theta, and if you have secant theta, that is 1 over cosine theta. So these are some of the basic trigonometric relationships that you should be familiar with. And of course, it is also helpful if you know some basic trigonometric identities, such as sine squared theta plus cos squared theta is equal to 1. For example, this is quite common. And other trigonometric identity will be 1 plus tangent squared theta is equal to secant squared theta. Right, if you're not sure or if you don't remember all this, you can always refer to basic or mathematics textbook, standard mathematical textbook, and you can find more examples related to trigonometric relationships or trigonometric identities. Yeah. Okay, so I think these rules given in the purple box here are very helpful if you are able to remember all of them. But let's say that you can't do that. I think the two basic rules that you need to remember will be this one, which is when you derive or when you find the derivative of sine of x, the answer is going to be cosine of x. And if you find the derivative of cosine of x, the derivative of that is going to be negative sine of x. So if you are able to remember these two rules here, you are already good to go, because I think the rest of the rules here can be easily derived based on your prior knowledge. Okay, so I'm going to demonstrate, for example, how can you derive this rule and this rule. So the rest here will be left for you guys to do it on your own. Okay, all right, let's get on with some of examples here. Let me just erase the ink on this slide. Okay, so how do we demonstrate that the derivative of tangent of x is going to be secant squared x? Okay, secant of x squared. Okay, right, let's start off with fx is equal to tangent of x, and we know that this is equal to sine of x over cosine of x. So if you want to find the derivative of this function, this is the same thing as having this expression here. And we already know how to derive such a function. We can assume this part to be f, and this is g. And we can apply the formula, which is gf prime minus fg prime over g squared. Yeah, so what is g? So let's get on with that. So g is cosine of x, and if you differentiate this one, sine of x, you will get cosine of x. So you will get cosine of x. Next, minus f is sine of x, and if you differentiate g, you will get negative sine of x over cosine of x, and you square it. And on the top part here, it can be further simplified as cosine x and you square it. So cosine of x times cosine of x, you get cosine of x and you square it, plus sine of x and you square it over cosine of x and you square it. Okay, so this result here based on the trigonometric identity is going to be equal to 1. So 1 cosine of x squared, and that can be written as 1 over cosine of x and you square it. And we know what is the relationship when you have 1 over cosine of x. So that will become secant. So secant of x squared. And this is the same thing if you write down as such, secant squared x. Okay, so there you go. That's the example, the example for this one. How can you get the derivative of tangent of x? Excuse me. Alright, now let's move on to the next example here. We are going to look at this one. Okay, how can you get the answer as such? So here we have a function which is cosecant of x, and we know that this is equal to 1 over sine of x, yeah? So if you want to find the derivative of this function, this is the same thing as having this expression given here. And again, we can follow the same idea which I have shown you just now. We can call this to be f, we can consider this to be g, and we can apply the formula which is this one, gf prime, fg prime over g squared. Okay, so now I'm just going to apply that formula straight away. Oh, sorry. So here what I have is g is sine of x. So if you differentiate a constant, you will get the answer is equal to 0, minus f is 1, and if you differentiate g, you will get cosine of x over sine of x, and you square it. Okay, next what you have is this one is going to be 0, so you have negative cosine of x over sine of x. So now sine x squared can be separated as such. You can separate them to be like this, and we know that if you just consider this part here, cosine of x over sine of x, this is cotangent of x. And if you consider this part, this is equal to having 1 over sine of x. So 1 over sine of x is cosecant of x. Okay, so we are going to write the final result as negative cotangent of x times with cosecant of x. Right, and if you want, you can rearrange this expression here so that it looks similar to the answer given here. So we can switch the position and it will become negative cosecant of x cotangent of x, and that is the answer as shown in this purple box here. So again, what I'm trying to say is it is good that if you are able to remember all the rules given here, and I believe with more exercises you will be able to do that. But let's say you can't remember, I think the basic formula that you should are these two, and by remembering these two you can just you will be able to work around and find the results of other derivative of trigonometric functions given here. Okay, maybe to wrap it up, let us try and do this simple example here. We have a function y which depends on x, and you are asked to differentiate this function. So what we need to do is dy dx. This is what the question is asking you to do. It's going to be written as such: x squared sine x. And based on this, I hope you are able to recognize that this one can be considered as f, and this can be considered as g. So you can apply the formula, which is fg prime plus gf prime, in order to find the derivative of this function. Yeah. Okay, so now without further ado, let us continue with the process. So f is x squared. Now you differentiate g, you will get cosine of x, plus g is sine of x, and you differentiate f, you will get 2x. And that can be, if you want, you can try and simplify that. Maybe this is what you can write down: 2x sine of x. And maybe what you can do is you can try to factor x out. So we have x cosine of x plus 2 sine of x, and I think that's all that we can do. That is the final answer. Yeah. Okay, I think that's all for now. Thank you very much for watching.